Hi, I'm Bruce. Welcome to the Baptronics Mountain Labs here in Colorado. And what I'm looking at today is a Keithley 179 TRMS digital multimeter. Some of the special features of this multimeter, the one that leaps out first of all, are the absolute jumbo-sized digits. Very easy to read from across the room. No, you don't have to get close or stand up or lean in or do anything like that. You just look at it and you know right away what you got. Second is that it's a 4.5 digit multimeter. So we've got some depth. So we can get down to we can resolve right down to a 10,000th of a volt. And right now we're putting in a voltage from our 343A DC voltage calibrator, our HP calibrator. And as you can see on my Keithley up here, the 2015, I'm getting 1.2345 volts DC. And you can see that this Keithley 179 is resolving it right down to the 10,000th of a volt. So 1.2345. Get a little bobble with the last digit, that's normal, but it's resolved it. This is a Keithley 179 TRMS digital multimeter. It's a 4.5 digit multimeter, and it's capable of measuring AC or DC voltages in ranges from 200 millivolts full scale to 1,000 volts. It does that in 5 ranges. We measure ohms in a low range or a high range, going from a scale of 0 to 2K up to 0 to 20 megohms in 5 ranges. And we measure amperage from about 200 microamps full scale on range 1 to about 2,000 milliamps or 2 amps on range 5. Very handy instrument, and it's a handsome instrument. It's a very nice bench meter. The displays are worth mentioning. We have 1/2-inch displays here versus standard smaller display. This fluke back here, for instance, the 8810, those are 3/10 of an inch. And not that they're hard. I wouldn't say that those are particularly hard to read, but these are just much easier. You set this thing on your bench, get the glare off of the glass, and you're not gonna have a problem deciding what the voltage is. And it's a very well-performing meter. We're going to run some tests through here. I like the way it's made. It's shielded very well, and the calibration is very straightforward on it. So this unit has been calibrated, and we're gonna check it out right now. Okay, we have the Keithley 179 set up in the DC volts position, and we're on the 200 millivolt range. We're feeding in a 100 millivolt signal from this Fluke 343A DC voltage calibrator. And we see that we are getting a reading of 100 right on the nose. Give or take a flashing 0.001, generally 0. If we are between 99.93 and 100.07, we're good. We're right on the money. 100.00. Okay, next we go to the 2 volt range. And we want to apply 1 volt. So turn that down, go up to 1 volt. We have 1 volt on there now. And we see we have 1 volt all across. If we were within 0.9995 and 1.0005, we're good. But we're 10000. Perfect. Okay, let's go to the 20 volt scale. And we want to go to 10 volts in. So that means I have to change my range. We're going to go up. You just see my decimal point change over here, and we've got 1, 0, so that's 10 volts coming in off the calibrator. Let's go ahead and put her back online. We are in 20 volts, yes. Bring it online, and we see that we have 9.999. Okay, 9.999. If we had a minimum of 9.995 or a maximum of 10.005, we're within the acceptable range, and we are right in the middle of it, looking good. Next, we go to the 200 volt range. We want to go with 100 volts coming in. Okay. We're 0 on this one. We're going to go up to 10. That would be 100 volts. And we're reading a flashing 99.99 to 100. So let's say it was 99.99. And you might want to throw a 5 on there, but it would be assumed. As long as we were within 99.95 and 100.05, we're good. And we're right in the middle. Okay, so now we go to the 1000 volt range, which in DC is really capable of up to 1200 volts peak. And in fact, our calibration point is 1000 volts. So they want us to put 1000 volts on here. This is why I've separated my leads. I have a separate positive lead and a negative lead. I didn't want to short internally. So let's bring this back down. And let's see. Take it offline, go to 1000 range, and we want to go there. So we have 10, 0, 0 point, and all zeros. So that's 1000 volts on this 1000 volt range. Double check, we're on the 1000 volt range here. I'm going to turn this thing on. Meter voltage is applied. And we see we have 1000.0 volts. So, .0. If we were within 999.5 and 1000.5, we're good. We were right on the money. That's the DC voltage. So we are within specs on DC voltage. Let's move on to the AC voltage. Okay, we are now set up in the AC volts 200 millivolt range. And we've switched our voltage source to this Fluke 5200A voltage source, and we are currently putting in 0.1 volts at 1 kilohertz, which is the requirement for the performance check. And as a double verification, I'm using my my Keithley 2015, and I see that I'm reading 10.001. I'm sorry, I'm reading 100.001 roughly millivolts AC. Okay, and we are getting 99.93 as a reading on the Keithley. So let's put that down here, 99.93. If we were within 99.15 and 100.85, we're good. We are in the middle, so we're better. Let's go to the 2-volt scale. Okay, and they want us to read 1 volt coming in. So if I want to go to 1 volt, range, change my range up here. I'm going to have to put myself back into operating mode. Okay. And it's a verification. We take a look up here. We see that we're running all 9s to, it's all 9s. Okay. And we are seeing here 0.9990. So 0.9990. If I was within 0.9925 and 1.0075, I'm good. I'm even better because I'm basically in between the two. Let's go to the 20 volt scale. Okay. And we want to read 10 volts. So if I want to go to 10 volts, put myself into standby for a moment and change my range and put myself on operate. And I see that 9 point in all 9s to 10.0, so 9.9999 to 10.0000. Little flashing going on. And what do I see on my meter? Something looks very similar. All 9s to a 10. I'm going to go ahead and call it a 10. 10.000, which is exactly what I wanted to get. I'm between 9.935 and 10.065, so we're beautiful. Now we want to go to the 200 volt scale. Okay. I want to go to 200 volt scale. I want to put 100 volts in here. So let's see, we want to go back to standby. Okay. We dialed ourselves up to 100.0. There's our 100 volts. We're going to put ourselves on operate. All right, and we see that we are 29.999 to 100.000. We are getting 100.00. So 100.00. It's exactly what we wanted. Okay, now we got a difficulty here because we need to go to 1,000 volt range, and quite frankly, can't do that much. 100's about as high as I can go, and I'll go to the 1,000 volt range, and we see that we've got 100.1 showing up on the range there. It's a good reading, it's just not 1,000 volts. Wish I could do better. So I do see that I'm reading the 100 volts on the 1,000 volt scale. And I wish I could do better for you, but I'd need another piece of equipment, an amplifier for that 5200A to give me the 1,000 volts AC. I don't have it. But the 100 is looking good, and we're going to move on. All right, we've got the Keithley 179 connected up in the high ohms position. And, excuse me, we've got it connected to this Resistostat 2 decade resistance box, which is a resistance box that has a 0.01% error on every step of the box. So very accurate. We're going to use it to test this Keithley. Well, right now, we're going to start in the high ohm 20K, position. We're going to use the performance check sheet that I generated using the Keithley manual, which is included with this unit. And to begin with, we start with 20K. We're going to apply 19 kiloohms to it. And we have our minimum and maximum read. We're going to see what we get in between. But to begin with, we're going to zero out the lead and any residual resistance that we have at 0. And we do that by this little 0 set screw that's inside the panel here. You wouldn't normally do this except on the most exacting of measurements. So because I am testing out this box for you, I consider that to be exacting. Okay, we zeroed it out. We're still on 0, and we're going to go to 19,000 ohms. So we're going, first of all, to go 10,000. And then we're going to dial in 9. So there's 19,000 ohms. And we've got a resistance reading of 18.996 or 7. I'm going to call it 6 and see how we turn out here. We expected to see 18.990 to 19.010, so good reading on the first one. Okay, so now we switch to the 200 kiloohm range, and we apply 190 kiloohms to it. Let me get back out of here. We're back on 0. This is a new range, so we want to make sure again that that we start out with a 0. All right, we got 0. And we want to apply 190,000 ohms. So there's 100 and then 90. All right. And we got 190.01. So let's write that down here. 190.01. We needed to be between 189.9 and 190.1. So we are beautifully there. Let's go to the 2000K range. And back to 0. We're zeroed OK. And we want to apply 1.9 megohms. And I'm going to need to use a different box. We'll pull my second box out because we have 1 megohm range on it, so bear with me. Okay, we're zeroed. We've got ourselves connected to my second resistostat box. We want to put 1,900,000 on here. And we've got 1,900,000 dead on. All right, so 1900.0. We want it to be between 1899 and 1901.1. We're beautifully there. Let's go to the next range. This is the 20 megohm range. Let's get back to 0. Okay, we were reading 0 on the meter. That's good. And we want to apply 19 megohms. I do not have the capability of presenting 19 megohms on this unit. The highest I can go is 11. I do have 11 megohms presented on here, and we're getting a 10.996 megohm reading. And to be within the 0.02% error range for the 11 megohms, we would have to be at 10.780 is the minimum. We're above that, and 11.220 is the maximum, and we're under that. We've got 10.996, so we are basically right within it, within the two ranges. I wish I could do the 19 megohms, but 11 is pretty doggone good, and we're getting an excellent reading. So I'm going to say we pass that. Let's go ahead and move on now, and we will go to the low ohms readings and see how we do. Okay, let's go ahead and remove this resistance and put ourselves in low ohms. Let's see, we're in ohms right now. Here's low. Okay, and we want to be in the 2K range for this next one. So there's 2K right there. And we want, see, we've got 0 ohms coming in off of the box. We want to adjust for 0 ohms on this range. Now let's tweak it just a hair more. Alright, now we want to read 1.9K. So we go 1K, 1.9K. And we've got a reading of 18996. 1.8996. Minimum is 1.8957. And the maximum is 1.9043. We are essentially 1.9. We're right there. And let's go to the 20K range. And again, remove our resistance. Go back to 0. See where we're at on the range. Zeroing it. It's difficult to do with one hand. I'm trying to film with the other. Come on. It's a good thing you don't have to do this. There we go. Often. All right, now we want to be on the 20K range. We are, and we want to put on a 19K. So 19, we go 10 plus 9. All right. We've got 19K we want, so here is 9K plus 10K, so that's 19K. And we are getting a reading of 19.003. Minimum was 18.957. We got 19.003. Maximum was 19.043. So we're well within that range. Let's go ahead to the 200K range. Remove resistance. Back to 0. Tweak our range for right about there. And we want 190K. So 190K, we'll get 100 off of here. There's 100. And 90. 190K, we've got 190.12. The minimum on this was 189.57. We got 190.12. And the maximum is 190.43. So we're well within that range. And then finally, the 2000K or 2 megohm range. Let's remove the resistance again. Go to 0. Little touch up on the all right. Yeah, almost. Yeah, close enough. All right. And we want to have 1900K, so it'll be 1.9 megohms. So we go 1 megohm, and then 0.9, and we got 1900.0, or right on the money. 1900.0. Minimum was 1.895.7, maximum was 1904.3. We're right on it. So that completes the ohms, and every one of our measurements was within the min and max, so we meet our criterion for performance, calibrated performance on this Keithley for ohms. Okay, we're in the 200 microamp current range, DC current. We are feeding a voltage in across a known resistance. We've got 10 volts coming in over a 100K resistor, through a 100K resistor. We are reading on it, across that resistor, we are reading right now 100.0304 millivolts. And 100 millivolts across that 100K resistor, and we've got 100.02 microvolts. So I'm going to take that as my reading, 100.02. If we were within 99.78 and 100.22, we're good. So we're good. All right, so we're going to go to the 2 milliamp range, and we're going to change our resistance to 10K, and we have 100.33 millivolts across a 10K resistance, and we're getting 0.9998. So I've got 0.9998. Our minimum was 0.9788. Our maximum was 1.022. We were right in there. Okay. We're going to go to the 20 milliamp range. And I'm going to change my load from this resistostat. I'm going to go to this load system here. Okay, here we're putting 10 volts across a 1K resistor, and we're observing 10.01 milliamps. So 10.01. If we were between 9.978 and 10.022, we're good. All right, and then now we want to do 100 milliamps. Okay, we've got 9.9995 volts across a 10 ohm resistor, and we've got 999 milliamps. So let's put 999, 997.8 minimum, 1002.2 maximum. We're in between. We're looking good. Okay, now here we got a problem. We want 20 amps scale. How do we do that? I don't even think we can do that with this particular meter. That would be the next model, the 20A. So we're done. This is it. So we can actually cross off that last measurement. Doesn't pertain to this model. So our DC current looks good. So we passed everything. All of our performance checks are beautiful. I'll provide the measurement sheet. You can check it yourself if you need to. And let's move on. Okay, so we've gone through everything with this nice looking meter. Just giving you a good look once more over the what the meter looks like. Underside you have a condensed operating instructions and some summary of features, ranges and such. Look at the outside of it. We have one little fade spot where there used to be a decal here, and the plastic has yellowed around what used to be the decal. The decal is gone, but a little fading, but it looks good. I mean, this is a beautiful looking instrument. Very large digits, as you can see, compared to just about any other meter that I have. It's at least twice the size. Very fine meter. Passed beautiful on all of the testing for DC voltage, AC voltage, ohms, and current. It's been calibrated, and it'll make a fine bench meter for somebody. Be a hard find to find a meter like this with this kind of readout that's been calibrated and going for this kind of price range. So, okay, we'll be providing the Keithley. We'll have a manual on CD. It's both operation, performance check, and some repair information. We have a set of test leads to go with it. So we get you started on that. We have the performance check sheet that we just went through on the video, and you'll be all set. So happy bidding. Thank you for listening, and good luck on this fine multimeter. Bye.